All right, we're back. Finishing up these notes. This is kind of the important part of this. Rational numbers as exponents. Rational here means like they could potentially be fractions. The exponents could possibly be fractions. And that has a very specific meaning in math. And this is important, so pay attention. As long as this number here is not negative, we'll deal with that later. If I have a to the m over n, a fraction like this, then you want to write a radical, and you put this thing as the radicand, it goes inside. This number, the denominator, is the index of the radical, and the power, or sorry, the numerator here becomes the power that you raise the fraction to. So again, the denominator of the fraction, the exponent, is the index of the radical. The numerator of the fraction becomes the power you raise it to. You could also write this like this if you wanted to. It doesn't matter whether you put the m on the outside or the inside. These things have exactly the same value. It doesn't make any difference which way you do it. A side note, and this is kind of related, but well, let me do this first. So, for example, if I said 16 to the 3/2, that's going to be, write the radical, put the 16 in there. And then this becomes the index of the radical. I'm not going to write it because the assumed index here is 2, like I said before. So I don't have to write the 2 if that's all it is. So I'm not going to. But then this is the power, and I raise it to the power. Now you know that the square root of 16 is 4. So this is like 4, and then to the third power. 4 to the third power is 64. So that's one way to do it. And it's a totally fine, legitimate way to do it. The other way is to do it like this. Instead, again, there's no index because it's 2. And the power I raise it to is 3. So this is the square root of 16 cubed. And everybody knows that 16 cubed, I'm doing this in my calculator right now because not everybody knows this, is 4,096. And the square root of 4,096 is 64, which is the same number I got here. So this is not surprising to me that it worked out this way. And you can ask yourself which one of these is easy, which method is easier, to do it this way or to do it this way. My opinion is that the first way is easier because instead of making 16 really big by cubing it, I make it small first and then I raise it to the power. This is easier to do like in your head, or just the numbers are smaller so there's less chance of making a mistake. So I like this way better. Both ways work. You can pick which one you like. The side note here is this 1 over n, and that's that a to the 1 over n is the nth root of a. And that's because like this becomes the index, so it goes right there. And the 1 is the first power, so whether I do it on the outside or the inside, raising something to the first power doesn't change it, so this is just the nth root of a. So like a really common one you run into is a to the 1/2, and that's the square root of a. Because the 2 becomes the index, which is assumed to be 2 anyway, so I don't have to write it. And the 1 is the power, which doesn't really apply. So a to the 1/2 is the square root of a. A to the 1/3 would be the cube root of a. Because again, the denominator becomes the index, and this becomes the power. I could do a to the 1 over anything. A to the 1/10 is the 10th root of a. So like we saw before, 1,024 to the 1/10 would be equal to 2. Because the 10th root of 1,024 is 2. We saw that in the previous video. So this shows up a lot, the 1 over a number as an exponent, and that just means it's like a radical where the index is the denominator of the fraction. So that's kind of a special case only because it happens so often. Here's one of your like the big skills you're going to have to be able to do, which is to rewrite these things given an expression in, this is what I would call exponential notation. Write it in radical notation. That means with radicals in it. So that means like converting this thing. So this goes in, this is the radicand. The denominator becomes the index, and this becomes the power. So you could evaluate this in some way. Like you could do 4 to the 4th, which I think is 256 And then you can do the cube root of that is not an even number, but if I say write it an equivalent expression, you can just leave it like this. I don't care. I just want to see that you know that this becomes the index and this becomes the power. Same thing here. I see the parentheses, which means that the whole thing in there is the radicand. This one becomes the power, which I don't have to write, and this becomes, the denominator becomes the index, so this is the fifth root of ABC. To the first, but again, I'm assuming that if I don't write an exponent, that the exponent is 1, so I don't have to write that. So here's a bunch of more examples here, which I'll run through. They're not going to take that long. So we saw before that a 1/2 power is like a square root. So this is just a square root of 7. Again, the index is 2, which is assumed, and the power is 1, which is assumed. So I can just write the radical 7. Exactly the same thing here, but now the radicand is x. This one, I would write my radical. The thing inside here is the radicand, goes on the inside. The denominator becomes the index, and this becomes the power. You can write it like that. Equivalently, you can write it like this. Either way. I kind of like this way better because the radical does the parentheses for me, but either way is fine. This one is a little trickier. There's 2 ways to do this. Like you can write it, like if you see this, you're like, well, I should write a radical. That's okay. The radical, now the index is 3, the radicand is n cubed, the power is 1, so I don't have to write it, but you know the cube root of n cubed is just equal to m. So that's a way to think about that. This one, pretty straightforward, I think. This is going to be a radical expression. The radicand will be z. The index of that radical is 2, so I don't have to write it. And I don't want you to write those. If it's assumed, I just leave it like that. And then I raise this to the 3rd power. Equivalently, you could put the power on the inside and make it the square root of z cubed. This one, to me, these two are very closely related. Again, I write a radical, and I put a 6 here, and I put the x cubed on the inside. And then there's like a 1 out here. I don't have to write it. So this is the 6th root of x cubed, which equals the square root of x. I'm going to show you that on the next slide, exactly how that happens, which is, boom, right there. So the deal here is we just used our newly learned tricks about radicals and exponents to do this. The 6, the radicand, the power. We just didn't have to worry about the power because it was 1. But we also know that when you raise a power to a power, which is what's happening here, you multiply the powers. So this is really x to the 3 times 1/6. 3 times 1/6 is 1/2. Next to the 1/2, we know is the square root of x. So to me, this is a simplified version. Simplified radical. And it's the one I would like you to write in there. Like if I ask you this question on the test, I would like the answer to be the square root of x. If you wrote this, you'd get some points for participating, basically, right? For like doing the things you're supposed to do here. But getting to here is really our goal. So this is the best answer to this question. Okay. Let me see what's left. That page is totally blank, so I don't have to do that one. Right. So last thing we're going to do is we're going to switch up the order in which we do these things, which means, I say we can do it the other way. I mean, like now it's given to you. This is going to be, it's given to you in radical form, meaning there's a radical in it, and I want you to turn it into exponential form. So the same rules apply, that the denominator is the index of the radical and the power is the numerator. I look at this and I say, well, it's going to be 7ab is the thing in the radicand, so that goes in parentheses. The power this thing is raised to is like 1 because there is no power, and the index is 5, so power over index. The index is 5, the power is 1 over 5, 7ab to the 1/5. Boom. Same thing here. I've got something we got an expression inside there, so I'm going to put it in parentheses, x cubed y over 4. Then I see there's no power that this whole thing is being raised to. The x is being raised to the third power, but since these things are not, I can't use that as my power. This whole thing is being raised to the first power. So it's a 1 on top, and the index of the radical is 7, so it's 1/7. Again, from radical form to exponential form. Same rules. Numerator is the power, denominator is the index. Radicand is the radicand. And this one actually has a power on it. I can see the thing in parentheses there is 5x, so I'm going to write that. And then I see there's no index here, but that means the index is 2. And the power here is 7. That's 7/2. Let me just reinforce the distinction between the power here and the power here. Here, the only thing in the radicand that's being raised to the third power is x, not the y and not the 4, which is why I can't use 3 as the power here. That's why it's 1. But here, everything in there is being raised to the 7th power. That's what the parentheses do. This could just as easily have been written as the square root of 5x to the 7th, like that. Either one of these things, these are exactly the same, which means this is how you write this, okay? 7 is the power because it is everything in there is being raised to the 7th power. So given that stuff, I'm going to break this video now. I'm going to check the homework, make sure that I've covered everything that's in it, and y'all should be good to go.